All right. So, welcome everybody, and please type your name into the chat so we have your record for data in the future. I hope everyone's doing well. There were some questions about certificates, so let me just say one more time what the status is. So, the certificates from prior years are already in Liberia. They're signed. They've been there for a long time, and just trying to figure out how to distribute them. Is that's still in progress? And then several people mentioned to me mistakes. So I think Rosh and Emmanuel and Joyce and Miata and Benson all had mistakes, so they wanted their name changed on the certificate. So I fixed all of that, and I gave those certificates today to Asamana Jabate, and he's going to get them into he's going to get them into Liberia with the next person who goes, and so hopefully they can get there in time for everybody to get their corrected certificate. So those should all be there. I think I've corrected every mistake that anyone has told me about. So if you still haven't told me and there's a mistake, I can try to get it to you. But I think at this point, that's everything. So again, I apologize for the mistakes, and I'll fix them for next time. Um, Question? Okay. Okay, so let's continue on where we left off then. So we had again, type your name into the chat if you need it, and if you want your record for the data distribution. And so let's just recall what we were talking about last time. Again, not the most technically advanced field in math, but maybe one of the most important ones that you're going to teach. Right. So the setup, we were doing word problems. So basically problems where the problem is given to you in terms of words, in terms of a story, and you need to set up the mathematics in order to get it right. Okay? So as we said, so the most important thing when teaching word problems is to set up a systematic way for approaching them. And so the method that I recommend is called KESCA, which stands for key, equation, solution, check, and answer. And this is just the review of these steps. So we did this last time. So in the key step, you write down your variables and what quantities they correspond to. There might be one variable, there might be two variables, there might be three. In the equation step, you set up one or more equations relating all of the variables. In the solution step, you solve the equation, I should say, or equations. Okay. In the check step, you plug in your solution to the original word problem to make sure that it's correct. And then once you've done this, you have your answer. And I would say these two steps over here, of course, they're optional. But when you can, it's good practice to make sure that you're correct. And it's sometimes nice to you get an answer and you see how it works with everything else. So you may have your own method that you prefer to use or that your textbook uses, and that's fine. The most important thing is that you have a method, right? Because word problems are very challenging for students. And even if some of them seem not so challenging for us, they're definitely challenging for the students. And they need a method. They can't just be left to figure it out. They need to know what is the procedure that they're going to follow when they have a word problem. So this is the procedure I'm going to use today, but if you want to use a different procedure, that's fine as long as you have a procedure. Okay. So a few people did the homework. So this is exercise one. So there's 16 bills in a pile. Some of them are $5 bills and the others are $10 bills. If there's 105 total bills in the pile, then how many bills of each denomination are there? Okay, so there's a few ways we can approach this, but does anybody want to set up the key for this? And two people who submitted this got the correct answer.
Hello, Andrew.
Hello, yes. Uh, Sorry, James?
Yes.
Yes. Okay. Can you set this up?
Yeah, I think we have the solid solution for that problem.
Mm-hmm.
For me, my solution, I use K and color Y.
Okay. So
So
what's the variables?
we don't know the number of 5 bills, and
Mm-hmm.
also we don't know the number of 10 bills.
Mm-hmm.
So in my solution, I said let K be the number of 5 bills
Mm-hmm. Good.
and Y be the number of 10 bills.
Oh, no audio. Great.
So since we know the total number of bills,
Mm-hmm.
we say K plus Y equals 16.
Exactly. So if these are k and y, then we have k plus y equals 16. Perfect. And then,
Yeah, we need to settle equation.
right. So k plus y equals 16 is the first equation, and then there's another equation for the amount of money.
Yes. The total value of bill is 105.
Mm-hmm.
So now we say 5K.
Mm-hmm.
Hello, Andrew.
Yes, 5k, correct. Yep. 5k plus, right, James? Yeah, so 5k plus
5K plus 10Y.
10y, right?
10Y
Yeah, equals
is equal to 105.
105. Exactly. Perfect. So this is the total amount of money. Okay, good. So we have these two equations for our two variables, right? K plus y equals 16 and 5k plus 100y equals 105. And so there's several ways we could solve these. What's the method that you want to use to solve? So that's our key. These are our equations. And now we find
So
the solution.
you need a substitution method.
Okay, good method. So what do you substitute?
So we'll say 5.
Yeah,
Hello?
5.
Parenthesis OB.
Right. So what the substitution is you're going to say that k is equal to 16 minus y.
Yes.
Okay, great.
Yes, yes, sir. Hello, sir.
Okay, yes, Prince?
Hello.
Yes.
Yes. So is there is no substitution method we use one for elimination method? Will it not work?
Yeah. So you can use any method you want, right? So substitution works here. You can do elimination of variables. I like substitution because substitution is more parallel to right at the beginning. We could have said let k be the number of $5 bills, and then we could say let 16 minus k be the number of $10 bills because we know that there's 16 bills. So substitution is basically doing the same thing as that. It's just using two different variables and then substituting one of them. So I like what James did with substitution. And so if k here is 16 minus y, right, we end up getting that 5 times 16 minus y plus 10y equals 105. All right, so that's how James did this here. And now, James, do you want to finish solving?
Yes.
Sure. Mm-hmm.
So you have 80. You multiply 5 by 16, it will give you 80.
Right.
80 minus 5Y plus 10Y equal 105.
Okay. Plus 10y equals 105. Perfect.
So if you solve that, you get a value of Y to be 5.
Right, exactly. So let me just do this. That's the same as 80 plus 5y equals 105, which is the same thing as 5y equals 25, which is the same thing as y equals 5. right? And so if y equals 5, then what is k equal to?
So you just substitute the value of y back into the equation for
Exactly.
k.
Right over here, right? K equals 16 minus y, right?
Yeah.
Okay, great. K is 16 minus 5 is going to be 11. Okay, so that says 11 $5 bills and 5 $10 bills. Let's check. Well, 11 times 5 plus 5 times 10 is equal to 55 plus 50, which is equal to 105. Right? That's exactly what we wanted. We wanted $105 total. So there we have it, right? So this is correct. And so our answer, right, is 11 $5 bills and 5 $10 bills. Okay. All right. So this works well. This is perfect. It's a basic question, right? We have, and it has, the nice thing is that this is simple enough that all of our steps fit on one screen, right? We have our key, k and y, our equations. In this case, it's two equations for two variables. We have our solutions, which we use the substitution method, which everybody seems to like. So we'll use that method. We substituted for k to get an equation in y. We solve the equation in terms of y to get y equals 5, and then that let us get the value of k is 11. We checked our answer, 11 $5 bills and 5 $10 bills. Is that actually $105? Yes, it is. It gives you 105. And so then we have our final answer, 11 $5 bills and 5 $10 bills. Okay, so this is a standard type of word problem, and the method is pretty straightforward, right? Okay, so thank you, James. Answer is perfect. Any questions on this problem?
Hello,
Hello, yes, James. Other James, yes. Sorry, I'm not getting you. All right. Sorry, I'm not getting you now. Okay, let's go to the next question. So exercise 2, which I also got some correct submissions. Find two consecutive odd integers such that 1/3 the smaller plus twice the larger equals 7 more than the sum of the two numbers. Okay? So looks very different from the other problem, but it can be solved in the exact same way. Okay? The important thing is to just get the key in the equation right. After that, the solution is pretty mechanical. So what's our key? What do we want to set to be our variables? Oh, question. How do we get the equation 5k plus 6y equals 105? We never got that equation. We had 5k plus 10y equals 105 because the amount of money is $105. So it's 5 times the number of $5 bills plus 10 times the number of $10 bills is $105. That's the total amount of money. Yeah, so 5k plus 10y equals 105. It's just the total amount of money. Okay, total amount of money is 5 times the $5 bills plus 10 times the $10 bills. Okay, okay, good. Okay, so what do we want to take for our key? If we're going to use the variable x, it's asking for two consecutive odd integers. So what should we set x equal to?
I think we are looking for the smaller or integer.
Right. So let's let x be the smaller integer. Great. And then we want the larger integer also. And we may as well just call that, we know these are consecutive odd integers, right? So the second one has to be 2 greater than the first one, right? If the first one is 5, the second one's 7. If the first one is 13, the second one's 15, right? It's got to be 2 greater. So we can just say let x plus 2 equal the larger integer. Okay, so you can make them x and x plus 2. Okay, right? So now all that's left to do is translate the sentence into an equation, right? So this is our key. Our key is just we let x be the smaller integer, we let x plus 2 be the larger integer. So in this case, we only have one variable. So we're only going to need to have one equation. Okay, so what's our equation in this case? And if you'd rather type it into the chat, you can do that too. You can type or you can talk.
So we want tear.
Yeah. Mm-hmm.
One tear.
Mm-hmm.
Tan x.
Right. Mm-hmm.
Plus 2.
Mm-hmm.
Does it open?
Yeah.
X plus 2 plus a.
Mm-hmm.
Is equal to
Mm-hmm.
7 plus x.
7 plus, yeah.
Plus parenthesis open.
Mm-hmm.
X plus 2 plus c.
Perfect. Right. Right, so here we are, right? We have 1/3 x, 1/3 the smaller, plus twice the larger, 2 times x plus 2, equals 7 more than the sum of the two numbers. So 7 plus x plus 2, right? It's just breaking down the sentence into little parts and translating them all into equations, right? So 1/3 x plus 2 times x plus 2 equals 7 plus x plus 2. Okay, so just for time, let me go and write down this simplification. 1/3, sorry, not equals. Let's do this. So this is this tells us that you get 1/3 x plus 2x plus 4 equals 7 plus 2x plus 2, or in other words, is equal to 2x plus 9. Okay. And then we see that there's a 2x on both sides of the equation. So I can erase the 2x's. And we end up getting 1/3 x plus 4 equals 9, which gives us 1/3 x equals 5, subtracting 4 from both sides. And now multiplying both sides by 3 gives us x equals 15. Right, so this here is the solution. Right, x equals 15. All right, so let's check. Let's check. So the numbers here are 15 and 17, right? Numbers are 15 and 17. So let's see, 1/3 the smaller plus twice the larger. So 1/3 the smaller, that's 15, plus twice the larger, that's 17. And we want to know, does that equal to 7 more than the sum of the two numbers? Right, we want to know, are these two things equal? Well, simplifying it, we get 5 plus 34. We want to know, is that equal to 7 plus 15 plus 17? That equals 39. And the answer is yes. So this checks out, right? If you plug in the numbers, 15 and 17, then this works. Okay? So that means the answer, it asks what are the two consecutive odd integers. So the numbers are 15 and 17. Okay, so Isaac has a question. Can this be proved? So I'm not sure I completely understand the question. The problem can be solved, right? You set up an equation for these numbers, and the solution to that equation, the only solution to that equation, is x equals 15. And so then when you have that x equals 15, you check to see if that actually works. And in fact, it does work. You get that both sides are equal to 39. And so that means your answer, your two numbers that it asked for are 15 and 17. So I don't quite understand what it means to ask if it can be proved. I mean, it's just a problem that can be solved. Okay, good. Any questions on this? Okay, so let's move on to exercise 3, which was a little bit more difficult. Okay, so I think nobody submitted a solution for this one. So my claim is this looks more difficult, but you can solve it with exactly the same method. Is it okay if you plug in the value of x and get the correct number? Yes, by the way, Isaac, you're basically doing the check. If you plug in 15, then you're getting the correct number. The question is, how do you find 15 in the first place? Well, maybe you can guess it, but if you can't guess it, this is the method that helps you find it, right? It's by solving this equation that gives you x equals 15. Okay. Okay, so now we have this exercise 3, which is a little bit harder. So two people starting at a point on a circular 1 mile racetrack walk in opposite directions with uniform speeds and meet in 6 minutes. If they instead walk in the same direction, it takes the faster person 1 hour to gain a lap on the slower one. And the question is, what are their speeds? Okay, so not quite as straightforward as these first two questions, but I claim you can use the exact same method. All that you have to do is write the key correctly and write the equation correctly. Then everything works. So the key here is what? What are you trying to figure out? You want to know the speeds. Okay? So basically, I'm going to let x be equal to the slower speed. And you're going to want some sort of unit for this, right? So probably good to do in miles per minute. If we want to convert that to miles per hour later, that's fine. But we'll start with it at miles per minute. And we can let y be the faster speed. Miles per minute. Okay, that's our key. That's it. We have two things that we're trying to figure out, the slower speed and the faster speed. So what do we know about the equation? Well, it's going to be two equations because we have two variables. Well, what's the first piece of information? It says that if they walk in opposite directions around the track, they start at the same point and then they walk in opposite directions, then they meet each other in 6 minutes. So if they start here and they walk in opposite directions, then the total distance that they walk is 1 mile, right? Total distance walked is 1 mile. So, and it takes 6 minutes. So what this tells us is that 6 minutes times the first person's speed, that's x, plus 6 minutes times the second person's speed, that's y,
It's equal to 1.
exactly, is equal to 1. Perfect. So the first equation we get is 6x plus 6y equals 1. Okay. Now, what about the same direction? It says it takes the faster person 1 hour to gain a lap on the slower one. So that says
So
if the
now,
first,
so now
yes,
it'll be
James, you want to give the
60.
equation? Yep.
There will be 60.
Mm-hmm.
Parenthesis open.
Yep. Yep.
X minus Y
Right. So 60 times x minus y
is equal to 1.
is equal to 1. Exactly. And you know what? I'm going to rewrite this just separately, just to make it slightly easier. I'm going to write this 60x minus 60y. Well, actually, y is the faster speed, right? So this should really be 60y minus 60x is equal to 1. Okay, because 60y is how much the faster person walks in an hour, and 60x is how much the slower person walks in an hour, right? Okay, and so now we have our two systems of equations, and we can
So that
use,
will be linear equations.
yeah, so do you want to use substitution or do you want to use elimination of a variable? We can use either one. Why don't we use elimination just to get a new version? So we can multiply to get 60s here. So if this is 6x plus 6y equals 1, that says 60x plus 60y equals 10, right? And then this here is negative 60x plus 60y equals 1, right? All I did was rewrite this to put the negative 60x over here, and all I did was multiply this equation. I'll just say this equation was multiplied by 10. Okay. So I guess we can add these two equations together if we want. We can add these two equations together. And if we do that, the x's cancel each other out, and we're left with 120y equals 11, or y equals 11 over 120. Okay? And once you have that y equals 11 over 120, we can solve for x using the first equation. So we get 6x plus 6 times 11 over 120 is equal to 1, which gives us 6x plus the 6 divides into the 120 20 times. So 6x plus 11 over 20 equals 1, which gives us that 6x equals 1 minus 11 over 20, which is 9 over 20. And that gives us x equals 9 divided by 120. Okay, so this tells us that the slower speed is 9 over 120 miles per minute, and the faster speed is 11 over 120 miles per minute. Okay, so the solution, maybe I want to just give you a little bit of time with this slide in case you're taking notes. I'll write the solution on the next slide because we're out of space. So the solution is 11 over 120 miles per minute is the faster speed, 9 over 120 miles per minute is the slower speed, or if you want to do it in miles per hour, you have to multiply it by 60, and so that will give you 11 over 2, so 5.5 miles per hour, and this one will give you 4.5 miles per hour. So 5.5 miles per hour is a pretty fast walk. That's a very, very fast walk. 4.5 is also pretty fast. Okay, this is some speed walking here. So okay, let me just write that on the next page. These are the equations. We solve them. So the solution is the slower speed equals 11. Sorry, the slower speed is 9 over 120 miles per minute, or we can multiply by 60 minutes per hour to eliminate minutes and eliminate the 60 and the 120, which leaves us with a 2. And so this is equal to 9 halves mile per hour. And the faster speed equals 11 over 120 miles per minute. Or if you want to, you can multiply it by 60 minutes per hour. Again, eliminate the minutes and eliminate the 60 and the 120 for a 2. And this gives us 11 halves miles per hour. Okay. So this is the solution here. Yes, Miyata, question?
Yes, Doc, not question. I would like to, for the fourth question, I would like to submit my word problem so we can solve it together.
Okay, yes, we're almost there. Okay,
Okay.
so sounds good. Yes, you can do that. So this is good. And you know what I'm going to do just for matters of time? I'm going to leave the check as an exercise.
Okay.
Okay, I'm not going to do the check, but this answer is correct. Okay, so before we move to the submit your own word problem, are there any questions on this example? No. Okay. All right. So let's go to, okay, so Miata, let's do your question. So come up with your own word problem and solve it using the full method. So let's work the problem together.
Okay.
Yeah.
Let me read my question.
Yes, you can
So
read it, or if you want to, you can also type it into you can read it and type it into the chat if you want.
it says printer A can be
Mm-hmm.
a booklet in 30 minutes.
Okay.
Printer A can print rather a booklet in 30 minutes,
Mm-hmm.
and printer B can print one in 45 minutes.
Mm-hmm.
How long will it take both printers working together to complete one booklet?
Okay, so printer A can, sorry, printer
Can
A,
print a booklet in 30 minutes,
okay, and print a booklet in 30 minutes. Yes, sorry. Ugh, why is it not
while printer B will print in 45 minutes.
Sorry, something's wrong with my pen. I just need to see why it's not working. What's going on? Okay. Printer A. Ugh, what is going on? Why is my pen not working? Okay, can print a booklet in 30 minutes.
Yeah.
And printer B
Printer B can print
can
it
print
in 45 minutes.
good booklet in 45 minutes. How long does it take them together? Okay.
Right.
How long does it take them to print
To
a
complete.
booklet
Yeah.
together? Okay, great. Okay, so what do we use for the key here?
We express 1 over 30
Right.
per minute. Yeah.
So A's pace is equal
A
to
equals
1
1
over
over
30,
per minute.
and B's pace is
1
equal
over
to
45.
1 over 45. And we're going to let, maybe T because it's time, right? So T should be the time it takes to print the booklet together. Right? Good. Okay, so that's the key. So A's pace is 1/30th, B's pace is 1 over 45. This is booklets per minute. And T is the time it takes for them to print the booklet together. So what's the equation that we get? So how do we write down the equation?
Yeah, so T is equal to 1 over 30 plus 1 over 45.
Right. Why don't we say it like this? So 1 over 30 times t, right? Because that's the amount that A can print,
Yeah.
plus 1 over 45 times t. That's the amount that B prints in time t, equals what?
Um, so we want to consider a minute. How many seconds?
Right. So over here we
Yes,
have, if t is our
yes,
time, right, we want to solve for t, right? T is the variable we want to solve for. So we have here is, this is how much A prints in time t. This
yeah.
is how much B prints in time t. We want that total printing to be one booklet. So if this is the total amount printed over here, then what should we set that equal to over here? How much do we want to print?
Is that, will we use like X?
Well, it
Um,
doesn't need to be x. T is our variable already. We don't need another variable.
oh,
We're
okay.
we're looking basically here is a number of booklets.
So
And so we want, the problem says, right, you want to print one booklet.
find the common denominator in this
Right.
case.
Well, before we find the common denominator, we need to write the equation, right? So we need an
Okay,
equation here. And so the point is that the equation should be 1/30th times t plus 1/45th times t equals 1, right? Because you're printing one booklet. So you want to say that one booklet is equal to the amount that A can print plus the amount that B can print, right?
okay,
So yeah, so the key is to set up the equation so that it's 1/30th times t plus 1/45th times t equals 1. Then when we solve this, we can get the common denominator and do everything. But what you need first is this equation that's telling you both of these sides of this equation represent booklets, right? So this side is just one booklet, and this is how much gets printed in time t.
okay,
Okay? So now we'll solve this on another page. So we want to solve, so I'm just going to copy it again. So we have 1/30th t plus 1/45th t equals 1. And if we want to, we can pull out a t. So t equals, or sorry, t times 1/30th plus 1/45th equals 1. So now we have a common denominator. Okay, so Abraham has an answer that looks correct to me. So what is the common denominator with 30 and 45?
That's it. 90.
Exactly.
okay.
So we get 3 over 90 plus 2 over 90 is equal to 1. Or in other words, t times 5 over 90 is equal to 1. 5 over 90 reduces to 1 over 18. And so we now multiply both sides by 18, and we get t equals 18.
Okay.
Right? Great. So again, the key here, lowercase key, is we want to set up the correct equation. Once you can set up the correct equation, then doing the common denominators and everything is not that hard. But the hard
Yeah,
part is to actually write this down in the first place, that you have a variable you're trying to solve for, that's time. So you're going to call that
yeah.
t. And then you need to write this equation, 1/30th times t plus 1/45th times t equals 1. Right? Once you have that equation, the rest is not so bad. But where most of your students are going to make mistakes is that they're going to set up the wrong equation. Most of them, when they have the equation, they can solve it. But the hard part is to set up the wrong equation. So that's why we want to be careful and we want to say, all right, we're going to really write down everything that figures into the problem. We're going to have a pace for both of them. We're going to set our variable equal to this time, and then we're going to relate all of these numbers and variables in an equation. That means in time t, The number of booklets you can print is 1/30th T plus 1/45th T, and you want to know how long does it take to make that one booklet.
Thank you, Doc.
All right, you're welcome. Any questions here?
Hmm.
Okay, if anyone later wants to send me their own problem, that's fine. You can send it to me. You can send it to me in the chat. For now, I think we'll move on. Okay. So more complicated word problems. So we're going to be doing the same topic today, but just the algebra will get a little bit more complicated. So last week, and including on the homework, so every word problem we solved led to linear equations. Okay, maybe we had one linear equation, maybe we had two linear equations. So today, we're going to look at some word problems that lead to more complicated equations, so to quadratic equations, and other ones that lead to inequalities. And I'll say, regardless, the Keska method remains the same. You're still going to write down a key for your variables. You're still going to set up an equation. And the only difference is how do you solve the equation. So if it's not a linear equation, then you need to solve it some other way. Okay? That's the only place where anything is different. The setup, which again is the hard part, that just remains the same. Okay? So let's look at a very basic example. So this is a very basic quadratic example. So the sum of two numbers is 18 and their product is 56. What are the two numbers? Right? So I could say, all right, I'm just going to do this one because it's kind of a silly example. So for my key here, I could say let x equal the first number. And I'm going to let y equal the second number. And so what are my equations? Well, the sum of the two numbers is 18, so x plus y equals 18. And the product of the two numbers is 56, so xy equals 56. Now, usually, the easiest thing to do is I'm going to do a substitution here. If x plus y equals 18, then I can write y equals 18 minus x. Right? So y is going to be equal to 18 minus x. So maybe I'll say solution. We have to actually solve the equations. So y equals 18 minus x, which means I substitute that here, and I get x times 18 minus x equals 56. Or in other words, 18x minus x squared equals 56. Or if I want to move everything to one side, I could have 0 equals x squared minus 18x plus 56. Okay, so all I've done is manipulate this equation so that it becomes a quadratic equation. So we now have 0 equals x squared minus 18x plus 56. And the reason this problem's a little silly is how do you solve a quadratic equation like this? Well, you just do the exact same thing. You just find two numbers whose sum is 18 and whose product is 56, right? That's how you solve the quadratic equation. So we've set it up in this formal way, but nothing has really changed. I mean, you can use the quadratic formula or complete the square, but usually you would just guess here. You'd say, okay, what are two numbers where the sum is 18 or the sum is minus 18 and the product is 56? And in order to solve this, you're basically getting the answer to the quadratic equation, right? So you think about it long enough, and then you come up with 4 and 14, right? So solving this as a quadratic equation is going to give you 0 equals x minus 4 times x minus 14. But of course, you've solved the equation already, and you get that x equals 4 or x equals 14. Right? That's your solution. And then, so in any case, these are the two. So the numbers are 4 and 14. And then for our quick check, well, 4 plus 14 is 18, and 4 times 14 is 56. Check. So the answer The two numbers are 4 and 14. Okay. So I went through that one kind of fast, but it's kind of a silly problem, right? Because in the course of solving the equation, you actually just answer the problem. In order to solve this quadratic by factoring, you have to find two numbers whose sum is 18 or negative 18 and whose product is 56. So you find those numbers 4 and 14 in the middle of the problem. And so, of course, when you finally get the answer, you're going to have that the numbers are 4 and 14. Okay. So again, you can set this up with this method, having a key, setting up the equations. And what it actually leads you to is just the standard quadratic equation where factoring it exactly means finding two numbers whose sum is 18 and whose product is 56. Okay, so this example is a little bit silly, but there's going to be, we're going to do a bunch more examples that are going to be a little bit more interesting. Okay? So any questions about this? I don't want to spend too much time on this example because we'll see some better examples soon. Any questions here?
Yes, there's a question, Doc.
Yes, Miata.
I'm seeing x squared and I got confused how we got the x squared.
Because here we're doing we're distributing. So we have x times 18 minus x. So we have the x times 18, that gives us 18x, and then we have the x times x, and that gives us x squared.
Okay.
Yeah.
Yeah.
Should, in case the coefficient of x squared is more than 1, yeah, we're gonna have a case of that. But no, we'll do that in the third example.
Okay.
Okay. All right. Other questions? Okay. So quadratic example number 2. If the length of each side of a square is increased by 6, then the area is multiplied, spelled it wrong, is multiplied by 16. Find the length of one side of the original square. Okay. So our key in this case is very easy. Okay, so the key should just be, what do we want to find? Usually you want to set one of your variables to be the thing that you want to find. So what we want to find here is the length of one side of the original square. So let's take that as our key. We'll let x equal the side length of the original square. Okay. All right. The equation said, well, if we increase it by 6, we multiply the area by 16. So that's saying that if we take a square whose side length is 6 more than the original square, right, and we square that, right, this here is the area of the bigger square, well, then this should be equal to 16 times the area of the smaller square. Well, if x is the side length of the smaller square, the original square, that means that its area is just going to be x squared. Okay, so x plus 6 squared equals 16x squared. Okay, that's the equation. Okay, because this here is 16 times the area of the smaller square. Okay, good. Okay, so Enoch has expanded out the left-hand side. That's great. So how do we solve this? So for our solution, we have x squared plus 12x plus 36. Remember, to expand this out, we have to have the first one squared plus the second one squared plus 2 times the product of the terms. So James is getting x equals 2. Okay, we're getting a little ahead of ourselves. So, okay, equals 16x squared. And now, again, so we have a different kind of quadratic equation. We're going to need to move everything to the other side. So this is going to give us, if we move everything to the other side, we're going to get 0 equals, well, we have 16x squared minus x squared. So 16x squared minus x squared is 15x squared, and then minus 12x minus 36. So we get 0 equals 15x squared minus 12x minus 36. Okay, and Enoch says exactly, divide everything by 3, right? We may as well simplify. So if we divide everything by 3, we get 0 equals 5x squared minus 4x minus 12. Okay? So now there's several different methods that you can use to do one of these quadratic equations when you have that the coefficient of x squared is not 1. So you can always use the quadratic formula if you need to, but maybe we'll try to avoid doing that because this one comes out pretty nicely. You can guess the factorization. If you know that this is 5x squared, then you can guess that it's going to factor into 5x plus something times x plus something and try to figure out what those two somethings are. Or you can use this other method called it's a method that I only learned recently. I did not learn this as a student. So there's something called the AC method, which is good for solving quadratic equations that have a leading coefficient that's not equal to 1. Okay. So Enoch, which way do you want to do this?
Yeah, hello?
Yeah, hello?
That's
Yep.
the AC method.
Yeah, so if for me, we can use either way. So for me, we can solve this probably for very convenient. We can solve it using factorization method.
Okay, yeah, let's do that. So let's factor
Yeah,
this.
so the first thing we can decide to write the entire equation as 5x squared minus 4x minus 12 equals 0.
Mm-hmm. Yeah, so we have that.
Yeah, so then from there, we know that we are actually looking for two numbers. The first thing we are multiplying in our mind, we are multiplying 5 by negative 12. The value we get, you will know that we will have negative 60. Then we are looking for two numbers in our mind. Yeah, we are looking for two numbers in our mind. We can multiply to have a negative 60. If we add it, you get it. The middle term, which is a negative 4. So the value we are using.
Okay, good. So what you're doing is actually what I call the AC method. Okay, so that's good.
That's the AC method.
Okay.
Yeah, so this is what I call the AC method. So let's actually review that before we do this example. So I have it over here. Let's review this AC method for factoring quadratics. Right? So what Enoch said, which is correct, Enoch says find two numbers, maybe we'll call them P and Q, such that, well, we want P times Q, they multiply to AC, and we want them to add up to B. And so it turns out is if you can do this, then you rewrite ax squared plus bx plus c as ax squared plus px plus qx plus c. And then what happens is that it turns out that once you do that, you can factor the first two terms. And then you can also factor the second two terms. And then it turns out that it's going to simplify a lot. So we'll do this in the context of the previous question. So once you factor this one and this one, then the entire equation, or the entire expression will factor. So the key is you've got to find two numbers whose product is AC and whose sum is B. Once you can find those two numbers, then that makes this all easy to factor. Okay, great. So now let's go back to our original problem. So Enoch has this, right? So what do we want to do? We want to find P and Q such that, well, they have to multiply to AC, so that's 5 times minus 12. So their product is minus 60, and P plus Q should be equal to minus 4, right? And so what Enoch says, so he found the numbers. So the numbers, if you look in your Zoom chat, so those numbers are exactly 6 and 10. So this gives us that P is equal to 6 and Q is equal to minus 10. Okay, because 6 times minus 10 is minus 60, and 6 plus minus 10 is minus 4. So then you do that. So you exactly rewrite it as 0 equals 5x squared. Now, instead of writing minus 4x, we're going to write plus 6x minus 10x. So 5x squared plus 6x minus 10x plus 12. And actually, it's going to make it a little bit easier. I'm going to write it the other way. Let me write it this the other way. I'm going to write this as 5x squared minus 10x plus 6x plus 12. Okay? Great. And so now what happens? I take the first two terms, 5x squared minus 10x. I'm going to rewrite that as 5x times x minus 2, right? Because I can pull out a 5x. And then the 6x plus 12. Oh, wait, oh, sorry, that should be a minus 12. Sorry, I recopied that wrong. That should be minus 12. This I'm going to write as 6 times x minus 2. When you do this, you're always going to get, it's the magic of the method, you're always going to get the same factor here. So we have 5x plus times x minus 2 plus 6 times x minus 2. So exactly as Enoch has it in the chat, that's going to give us 5x plus 6 times x minus 2. Okay? And so equals 0, right? So, so exactly what do you get for the solution? We have 0 equals 5x plus 6 times x minus 2. So we get either 5x plus 6 equals 0 or x minus 2 equals 0. And this simplifies to, this tells us x equals negative 6 over 5 or x equals 2. But what's x supposed to be? X is the side length of a square, right? So can negative 6 over 5 be the side length of a square? And the answer is no, right? Squares have to have positive side lengths. So the only answer that we keep is 2. Okay, so we're going to eliminate this solution. This one doesn't count. And so we're left only with x equals 2. So that's going to be our solution is x equals 2. We'll check it because the checking is pretty easy. But before we check it, any questions about how we do this method? So, I mean, it's amazing. This is really a very nice method for solving these quadratics, and I didn't learn it until I was 40 years old. Somehow never taught to me in school. But it's a great method. And the key is, yeah, you find these P and Q that multiply to AC and add to B. And once you do that, you separate it into those two pieces, and you'll always get an easy factoring. Okay, so any questions so far? Okay, so now that we have 2, let's check. I'll add an extra page. So let's check. Well, the small square is 2 by 2, which has area 4. And the big square, remember, is the small square. You have to add 8. So it's 2 plus 6. Sorry, you have to add 6. 2 plus 6 by 2 plus 6. This is giving us, that's 8 times 8, which is 64. And we check that 64 indeed is 16 times 4, right? Big square has area 16 times that of the little square. So that's our check. So the answer is the original square has side length 2. Okay. Okay. So by the way, there is a shortcut to this question. We did this as a quadratic, but we could do this. You can do this as just a linear equation if you want to. There's a shortcut over here. And this relates to what we were talking about with geometry earlier. Right? So remember, if you want to multiply the area of a square by 16, area is a two-dimensional measurement, right? We were talking about this in geometry, right? A two-dimensional measurement, which means if you want to multiply area by 16, it's the same as multiplying the length of a side by 4, right? If you multiply the length of a side by 4, then the area gets multiplied by 4 squared, which is 16. So you could say, so we're saying if the length of each side of a square is increased by 6, we're saying the area is multiplied by 16. It's the same to say that the length is multiplied by 4. So I'm going to write it down here because it's so, well, maybe I'll write it on another page. So I'll say alternative solution. Well, you observe that multiplying area of a square by 16 is the same as multiplying the length by 4, right? Because the area gets multiplied by the square of the length, right? This is because 16 equals 4 squared. So then what do we have? We just have that when we add 6, so the equation in this case, same key, but the equation in this case says x plus 6, when I add 6 to the length of a side, that should be the same thing as multiplying x by 4, right? This is the big side. Side of big square. And this here is side of small square. Right? And so now that you have this, this is a very easy linear equation. You subtract x from both sides. This gives you that 6 equals 3x and x equals 2. And you don't have to do any quadratic equations at all. Right? It's the same answer that we got before, and it's a shortcut solution. Because if it's saying something about areas of squares, you can convert that to saying something about lengths of sides of squares. Okay, because it's just saying that the side of the big square is going to be 4 times, it's going to be 4 times the side of the small square. When you set it up like that, you only have a linear equation. So either method is correct, but actually this linear equation is a little bit easier. But you have to realize this concept from geometry, that multiplying area of a square by a certain amount is the same as multiplying the side of it by the square root of that amount. Okay. All right. Any questions here? Okay. All right, let's do one more example. Okay, so Mark rows downstream for 30 kilometers, then turns around and rows back to his original location. The total trip took 8 hours. If the current flow is 2 kilometers an hour, then what is Mark's rowing speed in still water? Also, looks a little different from these earlier examples, but we can solve it. That's the moral of this story, is that any of these word problems can all be solved with the exact same method. We just need to set up the equation correctly. Right? So what's our key here? Well, we want to know what's Mark's rowing speed in still water. So we may as well make that the variable that we're going to solve for. Right? So we'll let x equal Mark's rowing speed in still water. Okay. Okay, that's it. That's the entire key, right? The speed is its Mark's rowing speed in still water. Okay. So what do we get for and maybe we can have one more variable. Maybe it's helpful. We'll say we'll let t equal to the time. What do I want to say? Let t be the time it takes for Mark to row downstream. Okay. And then also, then what that tells us is that 8 minus t is equal to the time it takes for Mark to row upstream. Okay. Okay. One time for Mark to row upstream. So it takes 8 hours total, right? Okay, so what do we have for equations? Okay. Well, what is Mark's, right? So we have to set up, we have, a priori, we have these two variables, x and t. So in the end, we're going to be able to solve for one in terms of the other. Okay? So what do we have for our equations? Well, we know that it's 30 kilometers to go downstream. And when Mark's going downstream, his rowing speed is x plus 2, right? Because he's going with the current. When he goes upstream, his rowing speed is x minus 2 because he's going against the current. So our equations are, we have that x plus 2 times t is equal to 30. Right? This is how much this is the rate and time that it takes Mark to do. So x plus 2 times t equals 30. This is our downstream equation. Okay. And then we also have an upstream equation, which is that x minus 2 times 8 minus t is also equal to 30. Right? This is again a rate and a time. And this equation is for upstream. Okay. So, all right. So we have, not the easiest set of two equations here, right? It's not like a standard linear type of equation, but it is two equations in two variables, right? So it should be something that we're able to solve. Okay, and probably the best thing for us to do here is to just try to make a substitution. Okay, this is the question, and the question is here on the screen. Okay, so we have a current flow that's 2 hours, so the rate upstream
Yeah.
times the time upstream is
Hello?
this. Yes, Enoch?
Hello?
Yeah,
Yeah, is the question like are two different equations, right? Equation one, equation two.
exactly. One is for the downstream equation and one is for the upstream equation.
Okay, so yeah, so to solve the equation is so simple. For example,
Mhm.
if you want to solve for the values of both x and t, the
Mhm.
first thing in equation one, we can solve for t by dividing all sides of the equation one by s plus 2. So we'll get t is equal to 30. So yeah, we will have t is equal to 30 over s plus 2.
Good.
Yeah, then yeah, we can now take equation number 2 and substitute the value of t in equation number 2 to solve for x.
Good. So we have x minus 2 times 8 minus t over x plus, or sorry, 8 minus, 30 over x plus 2 should be equal to 30. Right, so this is our substitution here, right?
Okay.
We substitute for t as this 30x plus 2. So let me say we're doing the solution stage now. So let me write solution.
Yeah, okay, so
Okay, good. So we're gonna certainly need another page to do this. So let me just copy this to another page. So let me see. We've got what do we have? X minus 2 times 8 minus 30 over x plus 2 is equal to 30. Okay.
yeah,
Yeah. So what do we need to do to solve something like this?
yeah.
Mm-hmm.
Yeah, so yeah, we know that the most difficult part of this expression is the second parenthesis on the right. So
Mm-hmm.
what we need to do, the fraction there, the 8 minus 30 all divided by s plus 2. We know that the 30 divided by s plus 2, the entire 30 divided by s plus 2, it can be written as the form of a over b. So in the form of c minus a over b. So
Mm-hmm.
there to combine it, we look for the least common denominator there first.
Sure. Okay. Well, and the
Yeah, so
denominator, there is no, right. So the denominator here is just x plus 2,
okay,
right?
so yeah,
So we could write this, sure. So we have x minus 2 times
okay, so
8x plus 2 minus 30 over x plus 2,
yeah, sure.
right,
So now
equals
it's
30.
not common to solve.
Good. And so now
Yeah,
what do we need to do? Eventually, we're going to turn this into a quadratic equation. So what do we have to multiply both sides by to get that quadratic equation?
yeah,
Well, what we'll do, we'll multiply by x plus 2, right? So this way we don't have any denominators anymore. So this will
yeah.
give
So
us that,
yeah,
right, x minus 2 times 8x plus 2 minus 30 is going to be equal to 30 times x plus 2, right? We have to multiply it all out. This way we multiplied both sides by x plus 2. That canceled out this denominator and moved the x plus 2 to the other side, right? So I'll just write times x plus 2 and times x plus 2. Okay. All right. So now we just have to multiply everything out. So this is going to give us, and maybe there's some simplifications, but I'll just multiply everything out. That's 8x plus 16 minus 30 equals 30x plus 60, right? We multiply this all out. And then let me simplify this. This is x minus 2 times 8x minus 14 equals 30x plus 60. And now I can FOIL this all out. So that's going to be 8x squared minus 16x minus 14x, and then plus 28 equals 30x plus 60. Right? This is just expanding this out. I have the x times the 8x is 8x squared. The minus 2 times the 8x is minus 16. x times minus 14 is minus 14x, and minus 2 times minus 14 is 28. Let's just keep simplifying it. So that's 8x squared minus 30x plus 28 equals 30x plus 60. And this, if I subtract the 30x plus 60 from both sides, we get 8x squared minus 60x minus 32 equals 0. And now again, I can divide by 4 to simplify things, and that gives me 2x squared minus 15x minus 8 equals 0. Okay, so we'll solve this using the same method. We'll do this AC method again. But before I go on to do that, I mean, I went through the algebra a little bit quick here. The algebra is a little bit annoying, but does anybody have any questions for how I got from up here down to a standard quadratic equation? We had to eliminate the denominator and eventually simplify everything out to get down to a standard quadratic equation. And remember, this all happened from our original set of two equations that we had to make a substitution of one into the other to get it to work. Okay, we started with one equation relating rate and time, and then another equation relating rate and time. Okay, so let's add one more page here. So I'm going to recopy the equation. So we have 2x squared minus 15x minus 8 equals 0. So let's do this AC method, right? We're going to find P and Q such that, well, we want P times Q is equal to 2 times negative 8, which is equal to negative 16. And we want P plus Q to be equal to negative 15, right? Well, this is pretty easy. Two numbers that multiply to minus 16 but add to minus 15, right? You're just going to get that P in this case is equal to minus 16 and Q is equal to 1. Right? And try a few things, but this is relatively easy to solve. Right? So P plus Q is minus 15 and P times Q is minus 16. This is the only way to do it. So we rewrite this as 2x squared minus 16x plus 1x minus 8 equals 0.
Yeah, hello.
Yes,
Yeah,
Enoch. Yep.
hello.
Yes. Yeah, Enoch, do you want to keep going? Right, so when you rewrite it this way, you get 2x times x minus 8 plus 1 times x minus 8 equals 0. And then, so that simplifies to 2x plus 1 times x minus 8 equals 0. And so that gives us that 2x plus 1 equals 0, or x minus 8 equals 0. And this tells us that x is equal to minus 1/2, or x is equal to 8. Right? And so x equals 1/2. Remember what x is. Never lose sight of your variables, right? So this is one of the lessons here, right? Never lose sight of your variables. You go back all the way to the beginning, and your variable here is x is Mark's rowing speed in still water. We don't want the rowing speed to be negative. We don't want him to be rowing backward. We want him to be rowing forward. Exactly. Okay, so James has these solutions. That's right. So what we want to not allow this answer because it's negative. So we only want to allow x equals 8, right? So the solution is the rowing speed in still water is 8, and I think our units were kilometers per hour. Yeah, kilometers per hour. So the rowing speed in still water is 8 kilometers per hour. Okay. And let's just do a mental check instead of writing down the check, let's just do a mental check because we're running out of time. So what happens if his speed in still water is 8 kilometers an hour? Then when he goes downstream, it's 10 kilometers an hour because he's going with the current. So 10 kilometers an hour to do 30 kilometers is 3 hours. When he goes back upstream, his rate is 6 kilometers an hour because he's going against the current. So 6 kilometers an hour for 30 kilometers is 5 hours. So it takes him 3 hours to go downstream and then 5 hours to go back upstream. Total trip is 8 hours. So that checks out. So that's exactly your check. You can figure out that the entire amount of time is going to be 8 hours. Okay? So even an innocent looking kind of rate times time equals distance problem, which normally would give you linear equations, when you introduce a current or a wind or something like that, it turns out that that can turn your equation into quadratic equation. Okay? So when you actually get these two equations, which are not in a standard form, so you have to use substitution, and when you do substitution, you have a bunch of algebra and it turns into a quadratic equation. But the key is to have your correct variables and set up your correct equation. And then the rest is substitution and things that you know how to do. Okay, and so this is the answer over here. All right, any questions on this? All right, it's a bit of a complicated example. Yeah, thank you, Hassan. It's easy to lose sight of your variables when you're teaching like this because I can only write one screen at a time. So I have to go back on screens to see where they are. On paper, it's a little bit easier not to lose sight of your variables because you have them ideally defined right at the top of the page. Okay. So, all right. So this is just a note on the AC method. We'll skip that. Okay, there's some stuff here about inequalities. Maybe I'll do this. I don't want to have to rush this, but there's not much on inequalities. Let me just do this example quickly, and then I'll skip the next example. We'll do it next time, and then I'll go to the homework. So if we have here that the length of a rectangle is 6 inches more than its width, if the perimeter of the rectangle is to be no more than 48 inches, what can we say about its width? So let me just say this pretty quickly. I'll just say that, the length, or what do we want to say about its width? So let's let x equal the width of the rectangle. And then if the length of the rectangle is 6 inches more than the width, then x plus 6 equals the length of the rectangle. Okay. And now, what's the equation here? Well, we want the perimeter of the rectangle to be no more than 48 inches, right? So what's the perimeter, right? We have our rectangle. This is x, let's say. Yeah, so this is x plus 6, and this is x. Then the perimeter of the rectangle is just going to be x plus 6 plus x plus 6. That's the perimeter, and we want it to be no more than 48 inches. So instead of saying that it's equal to 48, we now have an inequality. We say that it's less than or equal to 48, right? That's how you translate no more than into a word problem, right? Yeah.
Hello, Doc.
Yes, Miata?
Can we draw the rectangle to get better understanding?
Yeah, it's right here. This is the rectangle.
Okay.
Right, yeah. So there's the rectangle. This here is the perimeter. And then maybe I'll label these sides also. So if it's the rectangle, if one side is x, the opposite side is also x. And if one side is x plus 6, then the opposite side is also x plus 6. So we're saying the perimeter is no more than 48. So we got x plus 6 plus x plus x plus 6. That's all four sides is less than or equal to 48. And now you do the solution. So we just simplify this all. So x plus x plus 6 plus x plus x plus 6. If you collect all the x's, there are 4 of them. And if you collect all the 6's, there's 2 of them. So you get 4x plus 12 is less than or equal to 48, or 4x is less than or equal to 36, or x is less than or equal to 9. Okay. So x is less than or equal to 9. And that's it. I mean, that's what we can say about its width. It's a much more straightforward question. So we know that the width is at most 9 inches, right? Because x is the width. And we want to know what can we say about the width. Okay, so the width is at most 9 inches. And I'm going to, the check, right? If x equals 9, then the sides are 9, 15, 9, and 15. And we get that 9 plus 15 plus 9 plus 15 equals 48. Right, so that is the check. Okay, so if x equals 9, if we're at the threshold for the maximum permissible width, we get a perimeter of exactly 48. Okay, so that's the threshold there. So this is basically the same thing as a linear equation. It's just you replace it with an inequality instead. It makes really no difference for solving it, at the very least, because the only thing you need to be careful with inequalities is that when you divide an inequality by a positive number, it stays the same. But if you multiply or divide an inequality by a negative number, then you have to change the direction of the inequality. So if this was minus 4x equals 36, then you would have, or sorry, if this was minus 4x less than or equal to 36, then that would become x is greater than or equal to 9, or to minus 9, right? So when you multiply or divide by a negative number, you always have to switch the direction of an inequality. Otherwise, they basically act the same way as equalities. Okay, so there's a second example here that I don't want to rush through, so we're going to do this one next time. So the same question. So if a perimeter of a rectangle is 48 inches, if the area is at least 135 square inches, then what can we say about its width? So this we're going to do next time. This is an example of a so-called quadratic inequality. Okay, so we'll talk about that next time because I want to do it slowly, and we don't have enough time to do that slowly. Okay, so homework. So 3 problems for homework this week, and so they take a long time to write. So, it's important to translate these into mathematical equations. So the first one is kind of similar to the rowing question. Or no, the first one is kind of similar to the track question. So in a 10-mile bicycle race, Elijah covered the first 2 miles at a constant rate. He then sped up and rode his bike the last 8 miles at a rate that was 0.5 miles per minute faster. His overall time would have been 2 minutes faster had he ridden at the faster pace the entire time. And then the question is, what was his average speed for the whole race? Okay, so a little complicated, a little convoluted, but you can do it with the same method that we've been doing. So the hint is to first let x be Elijah's speed for the first 2 miles. So then first solve for x, then calculate how long the race took, and then calculate the average speed. Okay, but you're going to solve for x exactly by writing down the key. What does x mean? Writing down an equation. What is the equation that tells you this story and that tells you what x is? And then once you have x, you can calculate how long the race was. And then when you know how long the race is, it's 10 miles, and you know how long it takes, then you can calculate the average speed. Okay, so that's question 1. Question 2 is similar to this boat question. So when there's no wind, a plane traveling at a constant rate can cover the 1,000-kilometer round-trip distance from A to B and back in 10 hours. So it's 500 kilometers from A to B and then 500 kilometers back. If the wind blows from A toward B at k kilometers per hour, The trip is sped up by 25 minutes. Find K. Okay? So again, you're going to have some variables set up. You're going to have to let X be the plane's speed with no wind, and then K is equal to K. You're going to get two equations in terms of X and K, and you're going to have to make a substitution. You're going to get a quadratic equation, and that will help you solve this. So to do number 2, if you're stuck, you can go back and look at how we did this rowing example, because it's going to be pretty similar. And then the last one, number 3, is you've scored grades of 82, 76, 0, and 90 on your first 4 exams. There's one more exam. To pass the course requires an average grade of 70 on all 5 exams. Is it possible to pass? Number 3 is actually the easiest question. This is easier than 1 and 2. This is the kind of question a student might ask you at some point. Okay, so these are the 3 homework exercises. And so important logistical thing, there's no class next week. So I'm away next week. So the week after, on November 13th, we're going to begin a unit on probability and combinatorics, but we're also going to finish quadratic inequality word problems. Okay, all right. So thank you as always for your attention. Everybody can take one last chance to write their name if you haven't done that already. But I think we got everybody, so we should have a good record for data. So take one more minute to write your name down for data if you want, and then I'll stop the recording. Okay, any questions? Uh-huh. Okay, you're welcome. Yeah, I hope they can reach soon.
Okay, thank you, Andrew.
All right, you're welcome, AB. Okay, so I'm gonna
towards the when the work towards the certificate.
Mhm.